AC motors are used in a variety of industrial applications. They're used in applications from compressors, to pumps, to material handling, to theater automation. However, AC motors don't have the inherent intelligence to protect themselves from damage. That's where VFDs come in. VFDs offer several protection functions that can be used to protect the motor from damage as well as the machine. Here we'll be talking about several of those protection features as well as configurable fault reactions. When AC motors are driven at demanding operating points, they draw a lot of current. And a side effect of this high current is that the motor's temperature will rise. When the motor's temperature is allowed to rise uncontrollably, this can lead to damage of the motor. Some motors do include temperature sensors such as PTC, KTY, or PT1000 sensors. However, these are passive devices and they need to be read by an external device. With KEB drives, the temperature sensors can be read directly from the motor through the motor cable directly to the drive, where that data can be read out directly so the drive knows the motor's temperature. Torque limits are limits that are set to clamp down on the torque to prevent the torque from going above a certain level that could potentially damage the machine. For example, we can set universal torque limits. This is done so that the torque limit is applied in all directions. And also for applications where torque is only sensitive in one direction, say back driving, we can set a directional torque limit so that the torque limit is 0 in the reverse direction. One of the most common fault scenarios with a VFD and motor is a wiring issue. For example, when wiring up the motor, one phase might not be connected to the motor. KEB VFDs have a feature called phase current check. This allows the VFD to send out a test signal to detect and make sure that all three phases are continuous and also symmetrical. If the VFD detects any kind of abnormality in the wiring, it'll prevent the brake from releasing as well as preventing the application of any rotational energy. Power events like blackouts and brownouts are uncontrolled. However, KEB VFDs can respond to these events in a controlled manner. KEB drives offer a feature called the power off function. This allows KEB VFDs to respond to a power event by using the motor's inertia to power its own DC bus. This ensures that the drive remains powered even when power is lost externally. So KEB drives can then decelerate the motors in a controlled fashion. The built-in protection features of KEB drives will cover most general scenarios. However, application-specific problems require application-specific solutions. This is where external faults come in. KEB drives do include an external fault feature which allows the user to program their own customizable faults. For example, in an application like a hydraulic pump, it would be useful to avoid a high-pressure scenario. Just as important as the protection features themselves is the way that the drive responds in the event that one of these protection features is triggered. When a protection feature is triggered, the drive will typically enter a fault state. In this state, the drive won't be able to enter operation again until a fault reset command is triggered. However, it's not always desirable for the drive to immediately enter that fault state. For that reason, KEB drives also offer configurable fault reactions. So for example, if the motor's temperature crosses a critical state, instead of immediately entering a fault state, the drive can enter a controlled deceleration and then enter a fault state. KEB drives also offer a warning feature, which can allow the drive to avoid the fault scenario entirely. This operates as something of a pre-warning feature. So a warning threshold can be set below the critical level, which allows the drive to send out a signal when that warning threshold is crossed, and alert an external PLC or the operator directly. These protection features and configurable fault reactions lead to safer machine operation and avoid downtime. This saves the user both time and money. If you have any questions, please feel free to reach out to a KEB applications engineer to learn more.